I would actually like now to open the floor for any follow-up questions for Alessandro Manelli's talk, which we did not have time at the moment to entertain. And while those questions are being asked, I'd like the speakers to formulate comments to each other's talks, especially regards to the main points that were brought up with respect to contingency and inevitability and constraint. So, are there any questions for Alessandro Manelli?
I'm Philip Sloan, and I think it was interesting that 50 years ago, under the horizon, really hadn't appeared yet, was both regulatory genetics, which we've heard about from Michael Lynch's talk and all the questions introduced there, and also we've had reintroduced from something that wasn't in the synthesis, you might say. It was this great attention to questions of form, morphology, constraints, and so forth. And I wonder if, Professor Manelli, if you would address the question of how you can see now, from your perspective, the kind of questions you're looking at now interfacing with the kind of questions that Michael Lynch has raised, which have been those of fundamental regulatory genetics and so forth.
Thanks. Well, the interface between Evo-Devo and genetics is not so much in terms of population genetics, but rather in terms of developmental genetics. So not how genes are transmitted, but how genes are expressed, at which time in development, which spatial patterns, in developing which cascade of control. Unfortunately, the area, between population genetics and developmental genetics with evolution perspective has attracted very little attention until now. There are a few very nice studies. For example, the study of Cliff Tabin, Arat Abjanov, about the expression of genes controlling the shape of the bill in some of the Darwin's finches. So we have a notion about the variation in the genes and the control of species differences which are of major relevance. But this is something that has still to be developed. On the other hand, something a bit different emerges from the example I mentioned before of the genes controlling the shape of the tepals, say, petals in the flowers or orchids. So little genetic difference with major effects. This can be avenue further.
I am Gennaro Letta. I have also a question for Sandro Minelli. You stress very much the issue of contingency, but
the issue of
contingency in evolution and in development. But your own model of evolutionary mates does not show that there are structural and even functional constraints that allow and even oblige to certain divergences and also to certain convergences.
Well, the type of constraints is risk just a verbal tool. I would like to know what would you actually would mean. In a sense, by constraint we use sometimes terms of concept to describe the pattern. Something is constrained if it happens not very often. There is nothing. I cannot say any serious, say, object process corresponding to the definition of constraint. It's just a statement of the more or less high probability of something to occur. I don't think it is anything worth of independent status in our science.
But there are a lot of constraints even at a pure physical level. For instance, if you have small animals, like insects, they cannot have they must necessarily have some external protection because the amount of water that is released is too big. They will die. So they might necessarily be covered with an external structure, you know. This is a necessity. On the other hand, the size of neural cell, this must be almost the same, according again to physical constraints and so on. So, constraints is very general. Every time that you have to do with complex systems, you have necessarily constraints. It's not only a game of words.
In this sense, we are speaking of constraints as the limit set by, say, the problem. But in developmental biology, we usually speak of constraint in the sense that the development is, say, canalized in this or that way. This is simply a description of what happens. It's not the individuation of different kinds of phenomena. It's just a word. It depends. At least in the kind of word of literature I use. Consequence of what? Of processes at the genetic or epigenetic level, which have their logic, their mechanics, which you can describe, and eventually you sum out the output of them and determine whether they are constrained or not. It's simply a description of pattern, in my view.
Actually, I would like to try to move on to a different topic if possible.
Yes, sure. Only one more. Sandro, let me tell this as a last word, if you will. Patterns are as such unable to do anything in biology. Patterns are pure configurations. They have no power to do any effect. So you need something more than patterns. But these patterns are a word, are only a way of description.
Do we agree to disagree? Yeah. Thank you. I was hoping that I could have the speakers respond to each other, if at all possible. Do any of the speakers want to directly say something about what the other people have said?
I'm not sure exactly how to do this, but well, I really appreciated Simon's talk because he mentioned about, well, how many myths were there? Okay, about 9 that I didn't get to. So, and I think it's fair to say I'm in general agreement, although Simon's focus was at the phenotypic level more, and I'm focusing more on the genome level. But I'd like to point out a dramatic example of repeated evolution at the genome level, and that has to do with the genome architecture of land plants and animals. Land plants, so multicellularity evolved independently in land plants and animals. We're on exactly opposite sides of the root of the eukaryotic tree, and yet the genome architecture of land plants and animals is extraordinarily similar. We went down the same paths after, coincident with the evolution of multicellularity. I believe that's because of the increased power of random genetic drift. So there are a lot of parallels, I think, at the phenotypic level and the molecular level. For me, these days, it's a little easier to really pinpoint mechanisms at the molecular level. Alessandro's work on, is more or less an overview of Evo-Devo. My big problem with and this isn't a criticism of your talk, but the big problem I have with the field of Evo-Devo is it's really big on Devo and not so big on Evo in terms of mechanisms. And as I pointed out in my talk, for me, things aren't really solidly on the ground in terms of evolutionary phenomena until we can put it in a population genetics framework. And there has been some beginnings that I mentioned, some work that I've been involved with in the evolution of modularity and some work we've done on gene duplication and subfunctionalization and origin of tissue-specific expression patterns. It's just very, very beginnings here. But one thing to point out here, I think, that people really tend to forget is comparative biology is not evolutionary biology. It provides us with the data and the framework to think about things. But I have many colleagues in biology who say, I work on 2 organisms, I believe in natural selection. I'm an evolutionary biologist. The department doesn't have to hire any more evolutionary biologists. And that's a very common theme, even among biologists. And there is a real distinction between comparative biology and evolution.
Well, unfortunately, we are out of time. I do want everybody to have a break before the next session starts. This morning's session was a very long session, so we have 15 minutes before the next session starts on evolution and the human sciences. So that should also be interesting. But thank you very much for coming.